Welcome! In this session, we will explore LeetCode problem number 1374 titled Generate a String with Characters that have odd counts. The objective is to construct a string of length n where each character appears an odd number of times. We'll go through the problem requirements, possible approaches, and their complexities. Let's get started. The problem asks us to generate a string of length n such that each character in the string appears an odd number of times. The string should only use lowercase English letters, and if there are multiple valid outputs, we can return any one of them. For instance, if n is 4, the output string must have exactly 4 characters, and each character in that string must occur an odd number of times. The constraints ensure that n is at least 1 and at most 10,000, so we need to account for both small and large values of n in our solution. The output must strictly meet these criteria, ensuring odd character frequencies and the correct length of n. In the first example, we are given an input n equal to 4. One valid output is the string pa. Here, the character p appears 3 times, which is odd, and the character r appears once, which is also odd. The total length of the string is 4, satisfying the requirement. This demonstrates that we can use a combination of repeated characters and single characters to achieve the desired odd frequencies. Now, consider the next example where n is 2. A valid output in this case is the string xy. In this string, both x and y appear exactly once, and since 1 is an odd number, the condition is satisfied. The string length is also exactly 2, as required. Another example provided is when n equals 7. Here, the output AAAAA is valid because the character appears 7 times, which is an odd number. The string length of 7 matches the input, and the requirement is fully met. To summarize, the main requirements are that the string must be exactly n characters long, and every character in it must have an odd frequency. We are free to choose any lowercase English letters from A to Z, and there can be multiple valid solutions. For edge cases, when n is 1, we can simply return any single letter, like A. For an even n, we can use 2 different letters, each appearing once. For very large values of n, such as 10,000, we must ensure the solution is efficient and adheres to the constraints, generating a valid output without exceeding time limits. To solve this problem, the objective is to generate a string of length n where each character appears an odd number of times. Because multiple solutions are possible, we can focus on approaches that are both simple and efficient. First, let's consider a brute force approach. The intuition here is to iterate through all possible strings of length n using lowercase letters from A to Z and check if each character satisfies the odd count condition. The steps involve generating all possible permutations of strings, counting the frequency of each character, and validating whether the counts are odd. However, the complexity of this approach is a major drawback. Since generating all strings has exponential complexity, specifically O(26 to the power of n, and validating each string requires O(n), the overall complexity becomes infeasible for even moderately large values of n. While this approach guarantees correctness, it is computationally prohibitive and impractical for large inputs. This leads us to consider a more efficient strategy. A more practical solution is the constructive approach, which focuses on directly building a string that satisfies the problem's requirements. The key insight here is that the problem doesn't demand specific characters, only that their frequencies are odd. This allows us to construct a valid string efficiently. If n is odd, we can use a single character, such as a repeated n times. Since n is odd, the frequency of a will also be odd, satisfying the condition. If n is even, we can use 2 characters, for example, a repeated n 1 times and b once. This ensures it appears n 1 times, which is odd, and b appears once, which is also odd. The complexity of this approach is linear, O(n), which is optimal. While this approach lacks the variety of outputs possible with brute force, it is highly efficient and straightforward. Now, let's solidify our strategy by summarizing the key observations. The constructive solution was chosen because it offers several important advantages. First, it guarantees correctness by directly constructing a string that meets the odd count condition. Second, it achieves optimal time complexity, O(n), and requires minimal space. Additionally, it avoids unnecessary computations, making it both elegant and practical. When we compare this to the brute force method, the differences are clear. Brute force guarantees correctness but is computationally infeasible for large values of n due to its exponential complexity. In contrast, the constructive solution is efficient, easy to implement, and fully satisfies the problem requirements, even if it doesn't generate all possible valid strings, which, importantly, is not required by the problem. The final algorithm is straightforward. If n is odd, we return a string consisting of a repeated n times. If n is even, we return a string of a repeated n 1 times, followed by b. This ensures that all character frequencies are odd, providing a valid and efficient solution to the problem. In this problem, the task is to generate a string of length n such that each character in the string appears an odd number of times. This means character counts like 1, 3, 5, and so on are valid, and the length of the string must match the given n. Importantly, the problem allows for multiple valid solutions since there are many ways to create odd counts. This flexibility lets us focus on finding a simple and efficient solution. The key idea here is that we can use one or two distinct characters to achieve the desired properties. Specifically, when n is odd, we can create the string by repeating a single character n times. For example, if n is 5, using the character a repeated 5 times results in the string AAAA, which satisfies the condition because the count of a is odd. This approach is straightforward and ensures the solution is both correct and efficient. Now, when n is even, the situation changes slightly. Repeating a single character would result in an even count, which does not satisfy the problem's requirements. To handle this, we use two characters. One character is repeated n 1 times, which guarantees an odd count, and the second character is used once, which also results in an odd count. For instance, if n is 4, we can use a repeated 3 times and b once, resulting in the string ob. This approach ensures the total length of the string is exactly n while maintaining odd counts for all characters. To keep things simple, we can select it as the primary character and b as the secondary character. This eliminates unnecessary complexity while adhering to the problem's constraints. Additionally, we can generate these strings efficiently using string multiplication for repeated characters and concatenation to combine them. Finally, we return the constructed string as the result. The problem is made easier by recognizing a few key insights. First, repeating a single character n times satisfies the odd count condition when n itself is odd, which simplifies the logic significantly. Second, the problem's flexibility in accepting multiple valid solutions allows us to prioritize simplicity and efficiency. This means we can always default to the same characters, like a and b, without overcomplicating the solution. Third, the algorithm efficiently handles edge cases. For example, when n is 1, the smallest input, the output is simply a. Similarly, for larger values of n, up to 10 to the power of 4, the use of string multiplication and constant time operations ensures the solution remains performant. In terms of data structures, the only one we need is a string, which directly represents the output. Strings are ideal here because Python allows us to construct them efficiently using operations like multiplication and concatenation. The time complexity of this approach is O(n), dominated by the string construction process, and the space complexity is also O(n), as the string we generate occupies linear space. Let's look at a couple of examples to see how the algorithm works in practice. For an input of n equals 5, since n is odd, we can generate the string by repeating a single character 5 times. Using a, we compute a*5, which gives us the string AAAA. This satisfies the requirements, as the count of a is odd, and the length of the string matches n. Now, for an input of n equals 4, since n is even, we need to use two characters. We repeat a 3 times and add b once, resulting in a*3 plus b, which gives the string ob. This ensures the lengths add up to 4, and both characters have odd counts. These examples demonstrate how the algorithm handles both odd and even values of n efficiently while meeting all the problem's constraints. This solution effectively generates a string where all characters have odd counts, satisfying the constraints of the problem. ###explanation 1. Input handling. The function generate the string takes one parameter n, representing the desired length of the string. 2. Odd case. If n is odd, i.e., n%2 == 1, we can simply return a string of n repeated characters, e.g., a*n. This works because every character in the string will have an odd count. 3. Even case. If n is even, we slightly adjust the string to ensure every character still has an odd count. To do this, we use one character, a, repeated in 1 times, an odd number, and add one different character, b, to the end. This ensures the count of a is odd, n1, and the count of b is odd, 1. 4. Implementation. The implementation is compact and leverages Python string multiplication for efficiency. No extra data structures are used, ensuring minimal memory overhead. 5. Complexity. Time complexity, O, n, as we generate a string of length n. Space complexity, O, n, for the output string. This solution ensures correctness while being simple and efficient. This is the Java implementation of LeetCode problem number 1374, generate a string with characters that have odd counts. It mirrors the Python logic provided, with Java-specific features like type declarations and the use of the string.repeat method to construct the output string. The solution checks if the input n is odd or even and generates the string accordingly. In this problem, we're tasked with generating a string of length n where every character in the string appears an odd number of times. The solution hinges on whether n is odd or even. Let's start with an example where n is 4, an even number. The method generate the string is called with the input n equals 4. Since 4 is even, the program enters the else block. Here, we aim to create a string where one character appears an odd number of times by using one character repeated in 1 times and another character appearing once. Specifically, a is repeated 3 times, forming AAA, and then b is added to make ob. In the final output, a appears 3 times and b appears once, ensuring both counts are odd. Now let's consider the case where n is odd, such as n equals 5. The method generate the string is called with n equals 5. Since 5 is odd, the program enters the if block. The goal here is straightforward. We can achieve odd counts for all characters by repeating a single character n times. In this case, the character a is repeated 5 times, resulting in the string AAAAA. This ensures that the output meets the requirement, as the character a appears 5 times, which is odd. Finally, let's look at an example where n is 1, the smallest possible value for this problem. The method generate the string is called with n equals 1. Since 1 is odd, the program again enters the if block. For this input, we simply repeat a single character n times. Here, a is repeated once, resulting in the string a. This satisfies the requirements, as the character a appears exactly 1 time, which is odd. To summarize, when n is odd, we repeat a single character n times, and when n is even, we use n1 repetitions of one character and 1 repetition of another. This approach ensures the solution is both efficient, with a time complexity of O, n, and simple to implement while guaranteeing all character counts remain odd. The time complexity of the function generate the string is O, n, and this is determined by analyzing the operations performed by the function. First, the check to determine whether n is odd or even, using the modulus operation n%2, takes constant time, O1. This operation is computationally inexpensive and does not depend on the value of n. Next, the string generation is the dominant factor in the time complexity. When n is odd, the function constructs a string by repeating the character exactly n times. In Python, this repetition involves iterating n times to create the string, which results in an O(n) operation. Similarly, when n is even, the function constructs a string by repeating a for n1 times and appending a single b. The repetition part takes O(n1) time, which is asymptotically equivalent to O(n), and appending the character b is an O(1) operation. Since O(n) dominates the overall time here, the final time complexity is O(n). All other operations, like the conditional check and the string concatenation, are constant time and do not significantly affect the overall complexity. The space complexity of the function is O(n), and this is attributed to the memory required to store the generated string. The primary contributor to space usage is the new string that the function creates. Whether n is odd or even, the function always constructs a string of length n, and the memory required to store the string grows linearly with n. As such, this operation contributes O(n) to the space complexity. Beyond that, the function does not rely on additional data structures or significant auxiliary space. The input variable n and intermediate calculations, such as n%2, require only constant space, 1. Since there is no other memory-intensive operation, the overall space complexity is dominated by the storage of the generated string, making it n. When comparing this approach to brute force or naive methods, the efficiency of the given solution becomes evident. A brute force method might involve generating various strings with different character combinations and then verifying that the counts of each character are odd. Such an approach would involve iterating over multiple strings and performing checks, resulting in significantly higher time complexity, potentially n squared, or worse, depending on the implementation. In contrast, this solution is optimal because it directly constructs a valid string in n time without any unnecessary computations. Additionally, the time complexity remains linear, n, in all cases best, average, and worst, since the dominant operation, string generation, always depends on n. The space complexity is also n in all scenarios, as it is determined by the size of the output string, which is exactly n. Mathematically, the string repetition operation n iterates exactly n times, which justifies the n time complexity. Similarly, the space usage is proportional to the length of the output string, resulting in n space. With no nested loops, recursion, or additional data structures, the function maintains its linear performance in both time and space with respect to n. When solving this problem, there are a few common mistakes to watch out for. One major error is failing to ensure that all character counts are odd. For instance, if you create a string of length 4 using 2 A's and 2 B's, the counts of both characters are even, which violates the problem's constraints. The problem explicitly requires that every character in the string has an odd count. Another mistake is overcomplicating the solution. Some might try to distribute characters across the string using unnecessary iterations or complex logic. However, this problem can be tackled with a straightforward greedy or direct approach that avoids extra computations. Additionally, using inefficient data structures like hash maps or arrays to track character counts can waste space and time for such a simple task. Since the solution only involves 1 or 2 characters, lightweight logic is sufficient. Finally, be cautious about edge cases, particularly when n equals 1. If your solution assumes n is always even or greater than 1, it can lead to runtime errors. To avoid this, make sure you handle the base case for n equals 1 explicitly. Another mistake to avoid is using characters outside the lowercase English alphabet. The problem specifies that the string must only use characters from A to Z, so including anything else results in an invalid output. To address this, stick strictly to these 26 letters. Now, let's discuss some important insights for interviews. The core of this problem lies in ensuring all characters have odd frequencies. For an odd value of n, the simplest solution is to repeat a single character n times. For an even value of n, you can use one character n 1 times and a different character once. This ensures compliance with the constraints while keeping the solution concise. In terms of optimization, the solution should run in constant time and space, as there's no need for any operations proportional to n. Finally, this problem is an excellent example of how analyzing constraints can lead to a simple solution. Problems involving character frequencies or counting often have straightforward approaches if you avoid overthinking. During interviews, it's helpful to explain why you chose a minimalistic approach, especially in comparison to alternatives like using hash maps or frequency arrays. This problem also has connections to several related problems that involve frequency manipulation. For example, LeetCode 389, Find the Difference, requires analyzing character frequencies to determine the extra character. LeetCode 266, Palindrome Permutation, focuses on ensuring the character counts allow for a palindrome. In LeetCode 1221, Split a String in Balanced Strings, the goal is to split strings while adhering to certain constraints, and in LeetCode 49, Group Anagrams, frequency analysis plays a critical role in grouping words with the same character counts. Now, considering alternative approaches for solving this problem, the greedy method is the most efficient. If n is odd, use one character for the entire string. If n is even, use one character n 1 times and a second character once. This keeps computation and memory usage minimal. Another option is the frequency array approach, where you use an array to track character counts and ensure they are odd. However, this adds unnecessary complexity for such a simple problem. Lastly, a recursive approach could theoretically generate the string step by step while maintaining odd counts. Still, this method introduces overhead and is less efficient than iterative or direct solutions. For this problem, the greedy approach is clearly the most practical and optimal choice. Thank you for joining this walkthrough of LeetCode problem number 1374. We reviewed the objective, discussed the efficient approach, and highlighted key takeaways. Remember to practice similar problems to strengthen your problem-solving skills. Don't forget to like, comment, and subscribe for more content. See you in the next session. That's the end of this tutorial. I hope you found this explanation helpful for understanding the solution to this LeetCode problem. If you enjoyed this content, please consider subscribing to the channel for more coding tutorials and solutions. Feel free to leave a like if this video helped you, and don't hesitate to comment with any questions you might have. Thanks for watching, and happy coding!